Hello everyone. Myself Dr. Subramanian, Head of the Department of Chemical Engineering, Nanda Engineering College, Erode, Tamil Nadu. I welcome you all for my lecture series regarding process heat transfer, which is useful for UG Chemical Engineering and allied disciplines, and also for Diploma Chemical Petrochemical students also. These are the content what I going to tell you in lecture 1. First one is introduction about process heat transfer, and the second one is the difference between thermodynamics and heat transfer. Next one, application of heat transfer in process industries and allied industries. Then definition, then modes of heat transfer. These are the content to be discussed in this lecture 1. As we know that heat always moves from a warmer place to cooler place. To understand this, just in a picture you can able to see a cup of coffee which is at a temperature of 70 degrees Celsius, and it is placed in an environment. Its temperature is around 20 degrees Celsius. The coffee temperature is 70 degrees Celsius. We know that the heat transfers from hot coffee to the environment. You can see the heat flow, which is indicated in arrow symbol. As we know that hot objects in a cooler room will cool to room temperature. For example, if you take this hot coffee, the temperature of coffee is 70 degrees Celsius, and the coffee which is placed in the environment is 20 degrees Celsius. Till how long the heat transfers from coffee to the environment means till it reaches its equilibrium. That is, till the coffee temperature reaches to 20 degrees Celsius. Then if you see the cold objects in a warmer room will heat up to room temperature. For example, here I placed hot coffee, temperature 70 degrees Celsius, in a cool environment of 20 degrees Celsius. Here the coffee gets cooled to the environment temperature. Whereas if you keep any cold object in a hot room, the cold object temperature reaches the environment temperature. That is, when an object is placed in a cold room, a hot object is placed in a cold room, the temperature of the hot object decreases. Whereas if a cold object is placed in a warmer room, the cold object gets heated and it attains the temperature of the environment. Next, we'll see the difference between thermodynamics and heat transfer. First, we'll see the thermodynamics. What thermodynamics teaches means, or what we can understand from thermodynamics means, how much heat is transferred and how much work is done. Then, what is the final state of the system? These are three things. The thermodynamics we can understand from thermodynamics, or we can thermodynamics tell to us. One is how much it is transferred, then how much work is done, and final state of system. Whereas the heat transfer tells us in what mode that heat is transferred. The second one, at what rate heat is transferred. The third one is what is the temperature distribution inside that particular specimen or material or body. This is the difference between thermodynamics and heat transfer. Here you can able to see an example for that is thermodynamics and heat transfer. For this, you can able to understand, with this example you can able to understand how the difference between thermodynamics and heat transfer. For this I have taken a flask, thermo flask, that we call as thermos bottle. Inside a hot coffee or any hot material is placed, and you know that the thermos bottle was insulated. The thermodynamics simply tell us how much amount of heat is transferred from that is one equilibrium state to another equilibrium state. Whereas we normally interested to know how long the temperature of the coffee which will reach a particular temperature or room temperature. That thing cannot be learned from thermodynamics. Thermodynamics cannot able to tell us how long it will take the coffee which is placed in a thermos bottle to reach its temperature, that is equilibrium temperature, after half an hour or 1 hour. Okay, that thing can be understood from heat transfer. That is a major difference. Here, since it is an introduction part, I want to tell you about the difference between temperature and heat. We know that temperature is a measure of amount of energy which is possessed by a molecule or a substance, present in a molecule or of a substance. Whereas heat, on the other hand, is nothing but an energy which is in transit. That is, it is not static. It will be keep on dynamically. It will keep on moving. That is, okay. Spontaneously, if heat flows from a hotter body to a colder one, next we'll see the definition for temperature and heat. Temperature is a measure of amount of energy possessed by the molecule of a substance, whereas heat, on the other hand, is nothing but an energy which is in transit. That is, keep on changing, keep on moving on it. Next, we'll see the difference between temperature and heat. There's nothing but the definition for temperature. Temperature is a measure of amount of energy which is possessed by the molecule of a substance, whereas heat, on the other hand, which is in the form of energy which is in transit. That is, the heat suddenly flows from hotter body to a cooler one. These are some of the examples for heat transfer. As an application of heat transfer, you can take human body, then you can take air conditioning systems, then the heat transfer occurs in circuit boards, refrigerator, power plants, car radiators, and so on, and also in chemical industries and a lot of industries, process industries. This slide you can able to understand how the energy affect materials, how the materials are affected by energy. For this, I have taken two examples. One example is the water taken in a beaker, and the second one is I have taken 1 kg of copper. These are two different materials: water, which is in liquid state, and copper, which is in solid state. It's a metal, and these two materials need some amount of energy to increase their temperature by the same amount. If you take water, to increase the temperature of 1 kg of water by 1 degree Celsius, the water requires 4200 joules, whereas to increase temperature of 1 kg of copper by 1 degree Celsius, it requires 390 joules. Based on the types of material, the energy required to raise the temperature of water and copper are different. The mass of both the material, water and copper, are same, and the temperature you're going to rise are same, that is 1 degree Celsius, whereas the energy required is to raise the temperature of 1 degree Celsius, that is differing. That is, for water it's 4200 joules, whereas for copper it takes only 390 joules. So from this we can able to understand that water and copper require different amounts of energy. The reason is that they have different values of property that we call it as specific heat capacity. Okay. The specific heat capacity is defined as the amount of energy required to increase the temperature of 1 kg of material by 1 degree Celsius. Next we'll see that is how the particles are arranged in solid, liquid and gas. Solid, liquid and gas are associated with its energy content. In solid phase, the molecules or atoms are very closely packed to give a rigid structure. By seeing the picture, you can able to understand that there is a molecules or atoms which are arranged in the solid material are rigidly packed. Next, in liquid phase, you can see the atoms or molecules are somewhat loosely packed here because the energy present in this molecules or atoms because of thermal energy. Okay, some amount of thermal energy is present in that, which keeps the molecules sufficiently apart. As a result, the rigidity loses because the atoms or molecules present in the liquid material will have some thermal energy. Because of that, these molecules are moving apart, so it looks slightly different from solid material. Next, if you see the gas phase, because of presence of addition energy in that molecules or atoms, the molecules are completely separated and they are free to move in the space. anywhere in the space. You can see the molecules are scattered in gas phase. This is how the molecules or atoms are present in. Heat transfer is a science which deals with the flow of heat from higher temperature to lower temperature. Already we know that heat, by the definition of heat is not static, it is transit. Suddenly it moves from higher temperature to lower temperature. Heat cannot be stored, and it's defined as the energy in transit due to the difference in the temperature of hot and cold bodies. Whenever there is a temperature difference between hot and cold body, the heat transfers from hot body to cold body. The study of heat transfer not only explains how the heat energy transports, but also predicts about the rate of heat transfer, that is, heat transfer rate per unit time. When a certain amount of water is evaporated or condensed, the amount of heat transferred in either of the process is same for vaporizing and for condensing. Certain amount of water, that is, heat transfer for both the cases are same, whereas the rate of heat transfer in evaporation and condensation, that differs. 3 different modes of heat transfer. First one is conduction, second one is convection, third one is radiation. First we'll see conduction. Conduction is the transfer of heat in a continuous substance without any observable motion of the matter. The matter does not move, whereas the energy which is present in the molecule will transfer. There is another definition for conduction. Conduction is the transfer of energy from more energetic particles of a substance to the adjacent less energetic ones as a result of interaction between the particles. Substance molecules gets heated, means because of supply of heat energy, the molecule gets heated and the heat from one molecule moves to the next one, moves to the next molecule. From the second molecule, it moves to the adjacent molecules. Likewise, the heat transfers from one molecule to another molecule. The heat transfer in solid material will take place by conduction. Next, we'll see the different modes of heat transfer. First one is conduction. Next, we'll see the modes of heat transfer. Modes of heat transfer consist of 3 types. 3 different modes the heat transfer takes place. Next, we'll see the modes of heat transfer. The heat transfers in 3 different modes. First one is conduction, second one is convection, third one is radiation. First, we'll see the definition for conduction. Conduction is the transfer of heat in a continuous substance without any observable motion of the matter. Thus, heat conduction is essentially the transmission of energy by a molecular motion. The energy which is absorbed in the molecules will transfer to the heat energy is transferred to the next molecule. There is another definition for conduction. Conduction is the transfer of energy from the more energetic particles of a substance to the adjacent less energetic ones as a result of interaction between the particles. To understand the definition of conduction, just I have given some 3 pictures for easy understanding. Let us assume a solid material which is taken here. You can see the atoms, molecules which are present in the solid material. Just if you heat this solid material or metal, what happens means, first the outer surface of the metal gets heated. You can see the red portion here. The rod being get heated. If you see the second figure, the heat which are on the top layer or the layer of the metal moves towards the interior part of the metal where the molecules or atoms which are present inside the metal gets heated. You can see the color difference. The metal surface which is directly exposed to the heat surface are first heated. You can see that red color, and the outer you can see the other atoms are in blue color. The red color atoms are heated, or it acquires, or it has heat energy in it, and this heat energy it moves to the next atoms. The heat energy of this molecule higher than the heat energy of the adjacent molecule, which are in blue color. So the red color atoms will possess high energy, that is heat will be higher, whereas the blue color, so less heat. So the heat moves from this atom to the next one. The atoms gets energized by this heat energy, and the vibration of the atoms increases. It won't move, but it vibrates in its place, whereas the heat energy only transfers from the hot molecule to the adjacent cold molecules. In this you can see the atoms are vibrating on its place, and the atoms which are present adjacent to it gets heated. Like this, the conduction mode of heat transfer taking place in solid material. You can see that the energized particles which is present in the metal or atoms which are present in the metals are heated, and the heat moves to the other surface of the metal also. This is the way that is heat transfer taking place in solid material. Next one is convection. Convection is one of the mode of heat transfer. To know about the convection, there are two types of convection. One is natural convection or free convection. The second one is forced convection. Generally, when a macroscopic particle of a fluid moves from the region of hot to cold region, it carries with it a definite amount of enthalpy. Such a flow of enthalpy is known as convection. In natural convection or free convection, the movement of the particles, fluid particles, is due to the buoyancy force generated due to density difference of heated and colder region of the fluid. You can see here, just you consider a beaker consists of water. Just to heat the beaker is made of a solid material. By conduction mode of heat transfer, the outer surface of the beaker gets heated. From there, the heat moves to the water which is placed inside the beaker. When the water gets heated, the water molecules lose its density. Due to buoyancy, the water molecules moves upward. You can see the arrow mark where the less density water molecules are moving upward. That space was occupied by colder, higher density water molecules. Again it's heated, it loses density, and it will move upward. The third mode of heat transfer is radiation. Radiation refers to the transport of energy through space by electromagnetic waves. We have seen that the medium is required for the heat transfer in case of conduction and convection. For conduction, the medium required is solid surface, whereas in convection, solid and liquid surface. Solid or gas phase. Generally we call it as fluids. The next mode of the heat transfer is radiation. It refers to the transport of energy through space by electromagnetic waves. For conduction mode of heat transfer and convection mode of heat transfer, medium is required. For conduction, heat transfer takes place in solids, whereas conversion takes place in solids and fluid phases. Whereas in radiation, it does not require any medium, travels through vacuum also. Okay, that is empty space also, the radiation can. The electromagnetic waves, the radiation which are in the form of electromagnetic waves, travel at the velocity of light in vacuum. These waves are, when it is incident on any of the material, some of the fraction of radiation are absorbed, some fraction of radiation are reflected, and some are maybe transmitted by the matter based on the property of the matter. Best example for radiation is the heat energy from the sun which is falling on the earth.